A Fourier spectrum is a graph in which on the vertical axis is the volume expressed in decibel, and on the horizontal axis is the frequency expressed in hertz. So if I play a C4 on a keyboard that I have down here on my desk, I see that that has a fundamental frequency of 261 hertz as measured by this Fourier analyzer that I used ahead of time to record the spectrum of C4 on a piano. However, that's by no means the only frequency that exists, the only frequency that we hear when we play C4. In fact, 262 hertz is only the fundamental. It's what we call F1, or the first of the Fourier components. There are very many others. In this particular graph, there are 18, but it could go on much higher actually in frequency. So the important bit here is that the second component and the third and the fourth are precisely 262 by 2, by 3, by 4. And so on and so forth, up until 18 here. But all of this are integer multiples of the fundamental. Because it's a string, all Fourier components are present. We will see that in some other instruments that's not the case. But you can see that some of them have greater volume than others. For example, the first Fourier component has much greater volume than the third. By how much exactly? Let's see. This has 95 or thereabouts decibel on the vertical axis. The first Fourier component has 95 decibel on the vertical axis, whereas the third component has approximately 75 decibel on the vertical axis. That's a difference of 20 decibel. Because the decibel scale is a logarithmic scale, what that means is that a difference of 10 on the vertical axis means a ratio of 10 in amplitude or intensity. So if we go down 20 decibel from 95 to 75, we come down 100 times in sound pressure variation amplitude, in the sound wave amplitude. So 100 times is a big difference, right? Whereas if we go down 30 decibels, that's 3 orders of magnitude, a factor of 1,000 less amplitude or smaller amplitude. If we go down 40, it's 10,000. If we go down 50 decibel, it's 100,000. And that's the reason why when we hear this sound, we see a background here that starts at 100 times lower intensity than that. And that means that basically we can neglect it. All of this greatly colored background that we see in this graph from left to right, and starting at 50 at low frequencies and ending at approximately 30 at high frequency, all of this background is barely audible, especially in the presence of much louder sounds like these sharp, intense peaks that we see at the various Fourier components, at the various partials. I am now going to play a number of octaves. And in particular, I'm going to start from high frequency, from C8, and then go down one octave at a time to C7, C6, and so on. So I start from C8, which sounds like this, and I've recorded ahead of time the Fourier spectrum, neglect all of these peaks that are hardly audible, and pay attention to the C8 frequency at 4,185 hertz. Now I go down one octave to C7, that sounds like this, C8, C7, C8, C7. Now I'm alternating C8 and C7. And you can see clearly that C7 is a 1/2 frequency of C8. And in fact, the second harmonic, or the second Fourier component of C7, is twice the fundamental frequency, and it overlaps almost perfectly the frequency of C8. So the ratios for octaves really is 2:1. I go down another octave to C6, and what does C6 sound like? Let's find it on my keyboard. That's it. So C6, the first overtone of C6 is its second component, second Fourier component, or second harmonic, overlaps C7, and the second overtone or third harmonic doesn't overlap anything. The fourth harmonic overlaps approximately C8, again, not perfectly, not accurately. If I keep going down up one octave at a time to C5, I see it's half of C6, C4, 1/2 of C5, C3, 1/2 of C4 frequency, C2, 1/2 of C3, and finally C1, 1/2 of C2. As you can see, C1 and C2 have a tremendous number of higher partials, all of which are represented here, about half of which are barely audible. Above 2000, there's nothing above 40 decibels, so I don't think we're going to hear anything at these higher frequencies, but there are very many components. I counted 50 here, higher partials of C1 and something like 30 or so for C2. So interestingly, all of these higher partials overlap the higher octaves that we played earlier. So what do they sound like? Let's go see, starting from C1. That's very, very low frequency, as you can hear. C2. C3, C4, C5, C6, C7, and C8. Those of you with perfect pitch may have recognized that every time I went up one octave, the frequency doubled. Thank you.